This is going to be a quick video where we go through some examples around inverse trigonometry. So the first example that I want to talk about here is looking at this equation, sine of t equals 1/2. So this will, walking through this process will help us with the next example that we want to look at as well. So one of the things that I want to point out here is if we think about this equation in words, what we're doing is we're taking some input t, that's going to be our input, and what we do to it is we apply one function, we apply this sine function, and then the result of that process is the number 1/2. And so our goal is to figure out, what number do we input into the sine function to get a result of 1/2. So in order to undo this process, I have some sort of input and I applied the sine function, so I want to undo that. And the process of undoing that is applying the inverse function for sine, which we call arcsine. So I'm going to undo the sine function, and what I get is I'm left with this equation, which is t equals arcsine of 1/2. Okay, now we could look this up in our Common English chart, or we could plug it into a calculator, and what we get is we get arcsine of 1/2 is going to be pi over 6. Okay, so the tricky thing about this is we don't have this as the only solution, right? So we know that sine is periodic, and so there's going to be multiple solutions. So one of the things that could happen is I could add 2 pi to this and I would get another solution. Or I could add 4 pi or 6 pi. I could subtract it, right? So I could add or subtract any multiple of 2 pi, and I would get a solution to this. But we also have other solutions. So we think about the unit circle. What this is telling us is if I look at this angle right here, right? So if I were to look at this angle pi over 6, the y coordinate here would be 1/2, right? So this is telling me is sine of pi over 6 is equal to 1/2. But I also know that there's another point on the unit circle that's over here that's going to have the same y coordinate, and it's whatever shares a reference angle with this pi over 6. So I know that over here we would be at 5 pi over 6, and I would also have I would have the same reference angle of pi over 6, which means we have the same y coordinate, which is 1/2. And so through this process, we would get that t is equal to pi over 6 or 5 pi over 6. Okay, so the smallest positive solution. So oftentimes when you're looking at these types of problems, especially on web work, they're going to ask you for, hey, what's the smallest positive solution? And so the smallest positive solution is this one over here, which is 1/2. And the next smallest positive solution is this one over here, which is 5 pi over 6. Okay. And we know that as we go around, this is the only time sine is going to be 1/2. We have the same reference angles down here, but they're in quadrants 3 and 4, so sine is negative down there. And so if we extend this a bit further, we could get the general solution. So the general solutions to this would be pi over 6 plus 2 pi k for any integer k, or 5 pi over 6 plus 2 pi k for any integer k. Right. So what I'm going to do is switch over to Desmos here really quickly, so you can get a sense for what this looks like graphically. Right. So we want to know, hey, when does sine equal 1/2? So if I graph these two functions, the nice thing about Desmos is it will highlight a bunch of points for us. And so let's do this one first. So we get pi over 6, and if I add 2 pi to that, I'm going to be over here at 13 pi over 6. If I subtract, get negative 11 pi over 6. So these are all of the general solutions of the form. So anything sort of on the front half of this wave, these are going to be the general solutions of the form pi over 6 plus 2 pi k. And then anything on the back half of the wave, these are going to be our general solutions of the form 5 pi over 6 plus 2 pi k. So we get solutions that look something like this. All right, so for our next question that we're going to go through in this video, we're going to look at what happens if I have something on the inside of my trig function. Okay, so what that might look like is something like this. So you have tangent of 3x equals 1. Okay, so if tangent of 3x is equal to 1, what would we do for this problem? Okay, so it looks pretty similar to what we had before, except I've got this additional 3x on the inside that I'm going to have to deal with at some point. So again, thinking about this problem in words, we have an input here, which is x. Okay, so if our input is x, the first thing we do is multiply by 3, and then we take the tangent, and the result of that process is 1. Okay, so if I'm going to go in the backwards direction, I'm going to undo this. The first thing that I have to undo is the tangent, and then what I have to undo is I have to undo this multiplication by 3. Okay, so what we're going to do is we're going to think about this, and I'm going to undo my tangent function. And so what I would get is I would get 3x is equal to the arctan of 1. Okay, so arctan of 1, we saw just like before, is that this is equal to pi over 4. And so what we can do is we can again look at our unit circle. Okay, so if I take a look at my unit circle like this, I have this angle is pi over 4. And then over here, this is when I'm going to get tangent is equal to 1. Right, so we're over here at pi over 4. But I know that there's another point that corresponds to this. Okay, so tangent is going to be positive in quadrants 1, and it's also going to be positive in quadrant 3. So I have to think to myself, hey, what is the angle in quadrant 3 that has the same reference angle as pi over 4? And so that's going to be the angle that's down here. Right, so it goes down this way. And that angle is 5 pi over 4. Okay, so it's the way you want to think about this is you go over to pi, right? So you go over to pi, and I'm going to go another pi over 4. So that's going to be the same here. So pi plus pi over 4 is 5 pi over 4. Okay, so what I get, just like before, is I get two solutions. 3x, right? I get this 3x equals pi over 4, or 3x equals 5 pi over 4. Okay, so these are going to be my two solutions that are in the interval 0 to 2 pi. Okay, so we can think of these as our base solutions, and then we could get the general solution, right? So if I add 2 pi to any of these, we're going to get our general solution. Okay, so if I solve for this, we get a solution which is x is equal to pi over 12, or x is equal to 5 pi over 12. Right, so these are two solutions. They aren't the only solutions to this. Remember, we can add 2 pi k, but let's go ahead and jump over to Desmos to see this process play out. So we want to know, when does tangent of 3x, when is that equal to 1? Okay, so when I look at this, you can see that just like we did before, I can graph this, and then I get a bunch of solutions, right? So I can click on all these, and these will all be solutions to this equation. So the two that we found algebraically were pi over 12 and 5 pi over 12.